So hello guys, today we are going to solve a LeetCode question that goes by the name first completely painted row or column. First completely painted row or column. Question number is 2661. It is a medium level question. Let us first try to read the problem statement, what the problem statement says. Okay, so if I go to the problem statement, you are given a zero indexed integer array ARR and M into N integer matrix MAT. Okay, so you are given what you are given. You are first given an array. You first given an array and a matrix. And what is the size of a matrix? Size of the matrix is gonna be M into N. Okay. It is now given that ARR and MAT both contain all the integers in the range 1 to M into N. Okay, what does it mean to say by that? Basically, my array and my matrix, the elements of both of them will be integers, in the range 1 to m into n. That means if my array is of size 3 into 2 is equal to 6, so my elements should be 1, 2, 3, 4, 5, 6. These all elements should be contiguous. Like they should not occur in a contiguous manner, but all the elements from 1 to 6 would be present both in the array as well as the matrix. As well as the matrix. As well as the matrix. So you understood the question, right? The order of the elements is not defined. Order of elements is not defined. They can be in any order. They can be in any order. But the range is defined at 1 to m into n, the elements would be there, and all the elements will be there, no element would be skipped. Suppose if the range is from 1 to 8, so 1, 2, 3, 4, 6, 7, 8, all the elements will be present. This can't happen. Like one number is missing from this. Okay, so this can't happen, or any number is repeated. This can't happen because if you see the constraints, if you see the constraints, it is given that all the integers of AR are unique and all the integers of MAT are unique. Okay. Okay. So I'll move on to my problem statement. I'll again move on to my problem statement. Go through each index I in ARR starting from index 0 and paint the Selenium matrix containing the integer ARR I. Okay. So what I have to do as my array and my matrix both contain both contain the same elements. So what I'll try to do is I'll try to move like iterate my ARR, and if I encounter any number, suppose this is my matrix 1 2 3 4 5 6 7 8 9. So it is saying that, and this is my array 1 2 3 4 5 6 7 8 9. See, both contains equal elements, both contains the same elements. Okay, so it is saying that as you iterate through the array, whatever element you find here, you just mark it on the map also. You should mark it on the matrix also. Okay, so this should be marked, this one should be marked. Okay, and this one should be marked, this one I have marked. Okay, as I iterate, as I go into 2, this 2 should also be marked. As I go into 3, this 3 should also be marked. Okay, so this is what I have to do, and what I have to return? Return the smallest index I at which either a row or column will be completely painted in MAT. Okay, so I have to return the smallest index. Suppose in this case, if this is my indexes that I am writing in black, these are my indexes. If these are my indexes, then then this is what is my returning value in this case. I have to return 2 in this case. Why? Why? Because at the second index, I can see that I am able to fulfill my condition. I am able to paint the full row here in this case. So I am given that I have to paint the whole row or I have to paint the whole column by the smallest index possible. By the smallest index possible. And you have to traverse the array. You have to traverse the array. But you have to paint the row or a column in the minimum index, inside a minimum index range. Okay, inside a minimum index range. So either this or this, either rows or columns. These are the rows and these are the columns. These are the columns. Okay. So now if I want to just, this was a huge question. So I am basically given an array. If I try to summarize what the question says, I'm given an array and a matrix that will be a 2D matrix. Okay, that will be a 2D matrix. Both of these contain elements from 1 to m into n. Okay, both of these contain basically the same elements. And what I have to do is I have to simply traverse this array. And as I traverse every element that I encounter in my array, I have to mark it in my map on that position. The position will be given. The position will be given. You just have to mark it. And we have to return the shortest index. The shortest index till any of my rows or a column becomes fully painted, becomes fully painted. Okay, fully painted. So this is what I have to do. So what can be my brute force approach? What can be my brute force approach? Very simple. Okay, if I try to take a test case for this, 1 3 4 2. Suppose my array is given as 1 3 4 2. This is the one, right? 1 3 4 2, and my matrix is given as 1 4 2 3. Matrix is given as 1 4 2 3. Okay, so this is my matrix. This is my matrix. 1 4 2 3. Okay, so if I try to do what they are saying, that as you encounter this, you will just simply mark it in your map. You simply mark it in your map. Okay, I have marked it. I'll move forward. I go to 3. I go to 3. I have marked it. I'll move forward. Till now, any row or any column is not fully filled. Okay, not fully painted. So I'll move forward. As I move forward, I encounter 4. As I mark it, I can see that the first row is fully filled, is fully painted. So I'll just stop my iteration. I'll just stop my iteration. What I can see is, the second index, and the second index, 2 is my now minimum value. 2 is my minimum value, which my row gets painted. My row gets fully painted. Okay. So my brute force approach can be, in this case, what can be my brute force approach? What can be my brute force approach if this is 1 2 3 4 2 and 1 4 2 3? Okay, what can be my brute force approach? As I traverse through this array, if I say that you just traverse through this array, and every time you have an element, you store it in something, store it in a variable called a. Okay, any you can give any name as a choice. Okay, so just store it in something, and as you traverse the whole map, okay, you traverse the whole map and mark your element. As you find your element, you mark your element by some negative value, by some negative values. Why negative values? Why negative values? Because it is acting as an indicator. As my elements only contain in the range 1 to m into n, 1 to m into n, so there can't be any negative values. There can't be any negative values. But if I am storing a negative value, that means I have marked it. I have marked it. Okay, so I have marked it. Okay, as I go to 3, I'll mark this also. This becomes -1, and alongside I should check the condition also. If there is any column or any row that is getting fulfilled by marking that particular value by -1, by again iterating it, again iterating it. So you stop the iteration. Till now, no row column is fully filled. I go on to 4, I go on to 4, I mark it by -1. Then I check whether this is fully immersed, whether a row or column is fully painted or not. Okay, and as I can see, my row and my zeroth row contains -1. Okay, so this can be my answer. This can be my answer. And what is the number that I stop my iteration on? The second index. I stopped my iteration on the second index. Okay, so this is my answer. Okay, okay, cool. Sounds like a big problem. Sounds like a big problem rather than a solution. Rather than a solution, it sounds like a problem. It sounds like a problem. Right? Because you have to implement so many things that you have to traverse it again and again, again and again, and again and again. So it is gonna raise your time complexity by so much that it becomes n square plus n square somewhere raised to 2n square. Okay, this is not acceptable. This is not acceptable. This is not is gonna be a brute force. This is not gonna be an optimal solution. You can do this, but there is a better way to do it. So let's learn the better way. Not learn basically. Let us understand the better way. Okay. Suppose you are given with this 1 3 4 2. You are also given a matrix. You are also given a 2 into 2 matrix. You are also given a 2 into 2 matrix. Suppose it is given in the question that for every iteration, I have to mark it in my map. I have to mark it in my matrix that I have traversed this. I have traversed this. So I instead of traversing the map again, traversing the matrix again and again, I can simply use a map. I can simply use a map. What is the what I can make a map of? What is gonna be making my work easy? What is gonna be making my work easy? Yes, I can make a map of this ARR. I can make a map of this ARR. Not of this, because if I'm making this as the map, that doesn't solve my problem. That doesn't solve my problem. I still have to iterate it to know whether my row or column is full or not. Okay, so I'll make this array as my map. And what I'm gonna store? I'm gonna store the element with its index corresponding to its index. Okay, so if my 1 occurs at the 0th index, these are the indexes. My 1 occurs at my 0 index. Okay, so I'm gonna store it. 3 occurs at first index, 4 occurs at second index, and 2 occurs at the third index. No values are gonna be overwritten because all the elements are distinct. All the elements are distinct. So there is no possibility of the overwriting the values. Okay, overwriting the values. So this becomes my map. If I draw this again, 1 4 2. Sorry, what was my array? What was my array? 1 3 4 2. 1 3 4 2. And what was my matrix? 1 4 2 3. 1 4 2 3. Okay. And if I make a map out of these elements, what is my map gonna be looking like? This my map gonna be looking like? My map is gonna be looking like, if it contains the element as well as the index. My map is gonna be something like this. Element 1 contains is at index 0, 3 is at index 1, 4 is at index 2, and 2 is at index 3. Okay, so these are my values. These are my specific values. Okay, these are my values. So how is it gonna solve my problem? How? How? Suppose I say that I am gonna replace my values. I'm gonna replace my values in the matrix. I'm gonna replace my value in the matrix with the values, with the values, with their indexes. If one is occurring at the zero index, I'll simply replace it. Okay, if 4 is occurring at the second index, I'll simply replace it. So I'll replace the element's value with its index, Okay, so 2 is gonna be at the position 3 and 3 is gonna be at the position 1. And why I am doing this? Why I am doing this? Because eventually I need the index that I can stop at. I can minimum stop at. Okay, I can stop at the minimum. Okay, so this is what I get as my array. This is called what I get as my matrix. This is what I get as my matrix. Okay, this is what I get as my matrix. Okay, sounds cool. But what is the use of it? What I am trying to do with this? What I am trying to do with this is, as I'm storing my matrix indexes, I'm replacing my elements value with their indexes in the array, with their indexes in the array, with their indexes in the array. Okay, why I am doing this? Why I am doing this? Suppose this is 1 3 4 2. This is 1 4 2 3. Maybe it is wrong. Doesn't matter. Okay, I'm just gonna explain it. So what is my end goal? What is my end goal? My end goal, my end goal is to get the minimum index. My end goal is to get the minimum index at which my end goal is to get the minimum index at which my row or column gets filled. My row or column gets filled fully. My row or column gets filled fully. Okay, and I have to traverse from the zeroth element to the end element because I have to get the lowest value of the index that can fill my particular row or column, that can fill my any row or column. Okay, so I can simply replace these elements with their indexes. Okay, I can simply replace these elements with these indexes. Okay, so my 1 is at zeroth index, my 3 is at first index, 4th is at second index, and 2 is at third index. 2 is at third index. This is my map structure gonna look like. This is what my map structure is gonna look like. Okay. And if I try to replace these elements, values with the indexes, what I'm trying to do, if I'll refer the map and simply replace these values. 1 is replaced by 0. 1 is replaced by 0. 4 is replaced by 2. 2 is replaced by 3. 2 is replaced by 3. And 3 is gonna be replaced by 1. Is gonna be replaced by 1. Is gonna be replaced by 1. So this is what I get. This is what I get as my index values. Now this map contains all my index values. All my index values. Okay. If I ask you, how can I fill this column? What is the maximum element index? What is the maximum element index I have to get to? I have to get to fill this row. Fill this row. Maximum element index that I have to get to fill this row. Say, because if you say zero, no, no, because if I am stopping at 0, how I am gonna fill this second index? How I am gonna fill this second index? So my maximum element occurrence, so my maximum element index would be 2 in this case. Would be 2 in this case, right? 2 in this case. Why? Because if I am traversing till 2, suppose these are my indexes, this contains my x, y, z, k. Okay, these are my elements and this contains my indexes. Okay, so if I am traversing till the second index, that means I have already filled all both of these indexes. I've already filled both of these indexes, right? Right. Why? Because if I am traversing till here, that means I have traversed from 0 to that element. If I'm traversed to 0 to that element, that means if I'm doing the same thing again and again, I must have mapped it. I must have marked it to the map, to the matrix. I must have mapped it to the matrix. Okay, makes sense. Makes sense. Okay. What I'll try to do is I'll first this was my array indexes. This was my indexes. Okay. So in the first row, what I can say is 2 is my maximum value. 2 is my maximum value. I should get to fill this row. Okay. I got for the first row, I got 2. That's the maximum index. And for the second row, what is gonna be my maximum index? If I get till only the first position, will it gonna fill my third position index? No. No. Because obviously if I'm traveling in only the first position, my third position is not gonna get filled. So I'm taking the maximum element. My 3 is my maximum element. So for my second row, third index is that I should travel to. Third index is that I should travel to. Okay, that is gonna fill my element, fill my row. So, so it simply says that what this map simply says that is now my first row could be filled by traversing till the second index, and my second row can be filled by traversing to the third index. By traversing to the third index. But what I need, what I need, I need that I need the minimum index. I need the minimum index that should be there so that any of my row or column is filled. If I have two options that I can take 2 steps and fill my row, or I can take 3 steps and fill my row. What is the better way? What is the better way? So two is gonna be my better way. Two is gonna be my better way. Why? Because it is saving my steps. It is saving my steps. Saving my steps. Saving my steps. Exactly, right? Exactly. This is so logical. So I got it for the rows. I got it for the rows. I got my answer for the rows as 2. Exactly. Because got the answer for my rows as 2. So 2 is the minimum index I should travel to for any row to be filled. Okay. For any row to be filled, 2 is the minimum index that I should travel to. What about my columns? What about my columns? Maybe there is any other index, there is any other minimum index that can be there, I can travel to. So I should check my map again. 0231. 0231. Now I'll check for the columns. If I check for this column, this is the first column. If I take the one best index, this is the second column. Okay. I'll check for both of these columns. What is the maximum index that I should travel to? What is the index that I should travel to fill my row? This for this is it is 3. This it is 3 because before that I can't fill my column fully. Okay, and for the second column, what is the maximum index that I should travel to? It is 2. Obviously, because before 2, if you travel just to the first index, so the second index would be left out. Left. So 2 is my answer for this case. And I have to find the minimum possible value such that any of my column is filled. So what can be my answer? 2 can be my answer for this case. 2, 2 is the minimum of 2 and 3. What is the minimum of 2 and 3? It is 2. It is 2. So at last, I'll compare both of these. I'll compare both the rows and the columns. Both the rows and the columns. Maybe whether I can fill a row first or whether I can fill a column first. Whether I can fill a row first or whether I can fill a column first. So I'll take the minimum of both of these values, and that would be my answer. In this case, answer is gonna be 2. Answer is gonna be 2. So this is what we did. If I try to summarize what we did, okay, see, we are first simply basically checking, we are basically storing all of these elements in my map, all of these elements in my map, and then I'm replacing the values of the elements, replacing the value of the elements with the indexes, so the work becomes easy, because at last you want the indexes only, you don't need the element, right? So I'll just replace my replace my element matrix with the index matrix, okay, sounds like fun. Okay, with the index matrix. Now, what I'm gonna do with my index matrix? I'll try to examine it. I'll first examine it for rows, and then examine all the columns. First, I'll examine rows, then I'll examine all the columns. For the first row, what is the maximum index that I should get to fill the whole row? That is 2. Because before 2, if I stop, then this row can't be filled. So I have to take the maximum element of the row, of the current row. I have to take the maximum element of the current row. Okay, maximum element of the current row, and for the second row also I have to take the maximum element, because before this the row can't be filled. And I have to take the minimum of all the rows. Because as I am referring to all the rows, so I have maybe 3 or 4 options, or any number of options, that I can fill my row in 1 way, 2 way, 3 way, 4 way, 5 way, any number of ways possible. So I have to choose the minimum index, because that is what I am given. So 1 would be my answer in that case, because if I can reach the destination directly, if I can reach from Gurgaon to Delhi directly, why would I go to Faridabad and then go to Delhi? So there is no sense, right? So I'll take the minimum index. Okay. I'll do this for rows. And what I'll get is I'll get the minimum index. I'll get the minimum index to fill any row. Minimum index required to fill any row. And this I'll repeat for my columns. And my columns will give the minimum index to fill any column. And what I'll do at last is I'll take the minimum of these minimum of these. This will give me the overall minimum result. Sounds cool. Okay, so this is what I am doing. In this case, my answer was 2, and if I verify what was my answer is 2, right? If I do is for the second test case, 287413569. 2, okay, 287413569. 287413569. Okay, suppose this is my array that is given. What is my matrix? I'll map them to the indexes also. This is my 0th index, 2, 3rd, 4th, 5th, 6th, 7th, 8th. What is my matrix? My matrix is 325 146 879. 325 146 and then 879. 879. Okay. So this is my current matrix that is given to me as the element matrix. I have to convert the element matrix to the index matrix. What was my first step? First, I have to map all the elements, all the array elements to the indexes. Okay, so 2 is on my 0th position, 8 to my 1st position, 7 to 2nd position, 4 to the 3rd position, okay, 1 to 4th position, 3 to 5th position, 5th to 6th position, 6 to 7th position, and 9 to the 8th position. This is how my map is gonna look like. This is how my map is gonna look like. And if I try to remove these, replace these elements with their indexes, what I get is simply, I simply iterate. Okay, I simply iterate, and I'll do this stuff while iterating. I get onto the element 2. I get onto the element 2. Okay, I replace it by its index value. I'll replace it with the index value. Where is 3 present? 3 is present in the index 5. So 5 would be here. Okay, I'll replace this 2 by its index value. My 2 is present at the 0th index. I'll replace the value 5 with its index value. 5 is present at the 6th index. Okay, 5 is present at my 6th index. 5 is present at my 6th index. Okay, 1 is present at my 4th index. 1 is present at my 4th index. And 4 is present at my 3rd index. 4 is present at my 3rd index. 6 is present. Now I am currently here. 6 is present at my 7th index. 6 is present at my 7th index. Okay. 8 is present at my 1st index. It is present at my 1st index. 7 is present. 7 is present at my 2nd index. 9 is present at my 8th index. Present as at my 8th index. So I have simply mapped the element matrix to the index matrix. So now my matrix contains just the index values. I have replaced the element matrix values with the index values. What I get it as the matrix is 506, 506, 506, 437, 128. 506, 437, 128. So this is what I have got as an index. What was my first step? I have to check for all the rows. I have to check the maximum of each row, and minimum of all. Okay, minimum of all. So I'll traverse to the first row. What is my maximum of this row? 6. I'll traverse to the second row. What is my maximum? 7. I'll traverse it sequentially, one after another, comparing elements. Okay, comparing each element. This is my second element, and after I'll traverse the third row, I'll get it as 8. And what is my minimum of all of these? It is 6. For the rows, I get the answer as 6. Okay. Now I'll traverse the matrix for the columns. Okay. For the columns. So for the columns, I'll traverse in the first column. What is my maximum value? My maximum value is 5, because before that I cannot fill the current column. Okay. What is my second column maximum value? 3. What is my third column maximum value? 8. And what is the minimum of all these values? 3. Okay. So for the columns, what I get as the minimum value is 3. For the columns, what I get as minimum value is 3. So this box contains that these values show that for filling any row, I should get to the minimum element 6. And for the columns, I should get to the minimum element 3. So what would I take? I would take the minimum of both of these. What is my answer in this case? My answer is simply is 3. Okay. So that was my solution. I'll just code it now. Now this is my answer. That is gonna contain my maximum element. One is my unordered map, which will map my elements to my indexes. It will map my element to my indexes. Okay. I'm storing the size of the particular of like m into n. Row size, like column size into row size. So m contains matrix dot size, that contains the number of rows, and n contains the number of columns. Number of columns. Okay. I'll first map all the array elements to the indexes. This is what I'm gonna do first. Array of I equal to I. No value is gonna be collapsing or overlapping because the elements are unique. Okay. So there's no chance of overlapping. Okay. Okay. There's no chance of overlapping. Okay. So so there's no chance of overlapping. So now what I can do is I can first simply traverse the rows. How I can do it? I fix for suppose for traversing my rows. Suppose this is 1, 2, 3, 4, 5, 6, 7, 8, 9. For traversing the rows, what I'll do is I'll fix my column. And I'll iterate through my rows. That is 1, 2, 3 elements would be iterated. I'll fix my row and I'll simply iterate through my columns. Okay. So I'll traverse. This is gonna be my rows. I'll declare a C value. I'll tell why I'm declaring this. G++, and the C value is gonna be updated. It's gonna be storing the maximum value. Gonna be storing the maximum value of the current row. And what the answer should contain, the answer should be as minimum as possible because that is my answer. That is what I have to return. Minimum of answer and C. Okay. And I'll do the same for the columns. Just traverse through n. I just traverse to m. N and m means n means now they like this. I'm traversing through this. Okay. I just flip them. I just make it j and I, and at last I'll return answer. I'll return my answer. Okay. Oh, so it is mat and not matrix. Okay. I'll try to run it again. So I can see that it is submitted. It has successfully run. I try to submit. Yeah, it has been submitted. Okay. So if I try to explain my code again, if I try to explain my approach again, declaring the map, map stores the element and the ID. Okay. Traversing through the rows, storing the min of all the rows, then traversing through the columns and storing the min of all the columns. Yeah. Okay. Then I'm simply returning the overall minimum. I would return the overall minimum. What is my time complexity for this? As I am making I am only making two traverses, basically three. One is for storing and one is for two are for traversing. So my time complexity is somewhere between 2 into m plus array dot size. Okay, so this is my time complexity, and what is my space complexity? My space complexity is O of n. That is for the unordered map that I am using. Okay. So this is gonna be my space complexity. So this was the solution of the question, first completely painted row or column. I hope you guys like the solution. If you have any doubts, just bring it down in the comments. If you like the solution, do share, like and subscribe. Okay, thank you. Have a nice day. Bye bye.